Kia ora, it's Mrs. Goodson here, and this is the first video in Chemistry 3.4, which is all about thermochemical principles. Chemistry 3.4, as I said, is about thermochemistry. It's an external assessment which has an exam at the end of the year. It's worth 5 credits. There are 3 main parts to Chemistry 3.4. The first part is about periodic trends. The periodic table is about atoms and ions and electron configuration and atomic radii. The second part is about molecules, Lewis structure, shape, and polarity, and follows directly on from Chemistry 2.4. Energy. The third part is all about energy, and specifically enthalpy of reactions and entropy. Now, this first video is about how to write the electron configuration of the first 36 elements with SPD notation. So I'm going to explain what that is and what you need to know. Up until level 3 chemistry, this is the model of an atom that you'll be familiar with. There's a nucleus which contains protons and neutrons, and the electrons are thought of as in shells, energy shells, but more like planets orbiting the sun. So we've got 2 in the first shell, 8 in the second shell, and so on, up to 20. So we've got the first shell was 2 electrons, the second shell was 8, and then 2. So we just learned up to 20 electrons. This is an animation of the electrons flying around the nucleus in a certain path. However, we're going to move on from that model, and we're going to think about more of a quantum model. A quantum model doesn't think of the electron as flying around in certain paths. It could be found anywhere within a cloud around the nucleus. And so we're going to start to think about in terms of energy levels and probability of finding the electron in a certain energy level. We call these energy levels orbitals. So atomic orbitals, we still have the nucleus with the protons and neutrons in the middle. First shell has 2 electrons, and then we've got 8, 18, and 32. The electron shells that we talked about previously can be divided up into subshells. Electron subshells are made up of atomic orbitals, a region of space where an electron is most likely to be found. These atomic orbitals have precise and characteristic energies, which is dependent on its distance from the nucleus. These are the shapes of the subshells. So we've got S, which is closest, and it's a spherical shape, so that's the subshell S. The next subshell is P, and there are 3, and each can contain 2 electrons. So the S can contain 2 electrons, P can contain 6 electrons, and then the next one is D, and there are 5 D electrons, D orbitals, and they can each hold 2 electrons. So of course that means it can hold 10. After D is F, but you don't need to know F for level 3 chemistry. So we've got S, P, and then D. So each shell can be divided up into these subshells. Electron configuration is the arrangement of electrons in the subshells within an atom or an ion. The electrons will always want to fill the lowest energy orbitals first, off-bound, which is known as the off-bound principle. So we start with 1s2. 1s can fit 2 electrons. Then we've got 2s, 2p. The only tricky bit we get to is that the 4s suborbital is lower energy than 3d. So we fill 4s before 3d. The ground state is the orbitals closest to the nucleus. Sublevel 4s is further away from the nucleus than 3d, but it has a lower energy level shape orbital. Therefore, 4s will fill first. Okay, so we can, rather than write it in shells, we can think about electrons in boxes. So we want up to 36. So this is called Hund's rule. every orbital in a sublevel is singly occupied before any orbital is doubly occupied. So each orbital can have 2 electrons and they spin in opposite directions, so we use arrows to draw them. All of the electrons in singly occupied orbitals have the same spin. Okay, so we start off with hydrogen, which has 1 electron in the 1s, and then 2 electrons would be helium, and then we keep filling. When we get to the P, 2P, we're actually going to fill up singly first. We're going to follow Hund's rule before we fill up the rest of the orbital. The next one is 3s. It's got 2 electrons. 3p, do the single electrons first, and then we carry on. 4s, we fill 4s before 3d. 3d has 5 orbitals, so we can put electron in each one and then go back and fill them up until there's 10. 4p's got 6, so 1 in each, and then fill it up. And that's up to 36. Okay, so if we think about electrons, in each s orbital, there is 2 electrons. In p, there's 6. Another 3s is 2, 3p is 6, 4s is 2, 3d is 10, 4p is 6. So cumulatively, there's 2 electrons, 4 electrons, 2p, we're up to 10, 3s, we're up to 12, 3p, we're up to 18, 4s, we've filled 20, and then we do get up to 3d, we can fill up to 30, and then we get up to our 36. So on the next slide here, we've got a picture of the periodic table and how that relates to the suborbitals. So we can use the periodic table to work out the electron configuration. I'm going to use nitrogen as an example. Nitrogen is over here. Nitrogen is over here in the P block. Okay, so we've got the S block. This is the S block. Then over here we've got the P block, and in the middle we've got the D block. Okay, so nitrogen has an atomic number of 7. That means it's going to have 7 protons and 7 electrons. That's the atom that we're talking about. Okay, so 1s2, we've got 2 electrons so far. 2s2. So if we look here, we've got hydrogen and helium is 2, 1s2. So we've got this number here is how many electrons, okay? So we've got 2s2, so we've got 4 electrons so far. So we're trying to get to 7. So we've got this part here, we've filled up 2s, and then 2p is the next block. So we're going to just fill in 3 of those. So the next one is 2p3. So this here is the electron configuration for nitrogen. 1s2, 2s2, 2p3. I'm just going to show you the example of the noble gases. The noble gases are group 18. They've all got full shells. So helium is 1s2, or we can write it in a short form of helium in square brackets. Neon has 10 electrons, so it's 1s2, 2s2, 2p6. You can see that our first shell has 2 electrons, our second shell has 8 electrons, just how you learnt in earlier years, but now we divide it into subshells. Argon is 18, so it's going to be 1s2, 2s2, so we've got 2, and then we've got 8, and then we've got another 8 up here. So we've got 18. We can write it in the short form of argon. Kryptonite is the number 36, which is the highest we're going to go in level 2. So same as argon up to here. And then remember we said that 4s2 fills up first. So we write 4s2. 3d10 is going to be full in this case. And then 4p6. So altogether we get up to 36 electrons. We could add up all these small numbers and we get to 36, or we can write it in the short form. But get used to writing out this notation. Okay, and then in the next video, I'm going to show you some more examples, a couple of exceptions to the rules, and how to write electron configurations for ions. Thanks for your time.